Good evening, everyone. I'm Narayan. I welcome you all on behalf of the IIT Alumni Center, Bengaluru, for the 54th webinar. We have been having this long line of webinars since April 2020. It's been really a successful series. And in case you have missed it, you can find it in our YouTube channel. Today in this line of webinars, we have the opportunity to hear Mr. Sachin Sinha on why a novel data processing philosophy is key for emerging data trends. Sachin is the founder and CEO of IQLECT. He's an IT Kanpur BTech alumni, now lives in Bangalore. He's had over 20 years of experience in design, development, and leadership in building software products in database, distributed computing, and machine learning area. Prior to founding IQLECT, Sachin was the CTO of Jabong. He was also earlier at Amazon and Microsoft. Okay. Sachin has co-authored and published papers and developed several IPs in database technologies and concurrent parallel systems. He has also authored BangDB, a high-performance converged AI database platform. Our moderator this evening is Mr. Anand Talwai, a very familiar figure to all IITACB alumni, very active member. Anand is the co-founder and executive director at Next Wealth Entrepreneurs Private Limited. He has 30+ years of experience in the ICT industry and has a passion for leading greenfield profit-making companies, business divisions, and functions. He's an alumni of IIT Madras and ISC Bangalore. Anand Talwai began his career in ISRO as a scientist in the Apple Communication Satellite Project. He was part of the Wipro in the 80s and as the head of its quality and customer satisfaction function, and led as VP its communication division. Anand then went on to co-found and lead E4E Incorporated. He became a major factor leading to its expansion by creating and growing its portfolio companies. He's also a professor at IIM Bangalore, imparting his wealth of knowledge in business strategy, innovation, and entrepreneurship. Along with me, we have Dr. Sushila Venkatraman of IITACB. And before we start, I really encourage the audience and participants to engage in this webinar via the Q&A box, okay? Like the Q&A box and not the chat box. Okay. So really looking forward to this interesting webinar this evening. Over to you, Sachin.
Your audio, Sachin.
Yeah, I hope it's fine. Thank you very much for the introduction, Mr. Professor Narayan. And thanks everyone for giving me this opportunity today to talk about the topic. So I'll just get started. I'll share my screen and yeah, so this is based on the kind of experience that I've had so far in the industry. And this is totally based on the practical experiences over the years. And there are challenges and the struggles that we have gone through. And out of that, there are some learning that came out. And this is kind of a gist of it. Now, this is a too big a topic to be covered in a single session. So I've tried to sort of deal with some of the high level stuff and then little bit somewhere whenever it is required. I'll try to go and get into the details. So first of all, we need to appreciate why we need a data processing philosophy today. And what are the key emerging trends that we see in the market? And what are the driving forces around it? And also, what are the challenges that we face today because of this new trend that we see? And lastly, we'll see what is the proposition that we have today and how, in one of the ways, we can solve this problem. So, again, let's start from the very basic thing. So what is at the core? And we see that the core is obviously data, and it has been there since beginning. And what we have always wanted to do was to extract the intelligence from the data and then apply it in any ongoing operations. That operation could be totally domain specific. And if we are able to do that properly, then we see that there is a higher value that can be achieved. So this is still the same. The overall high level core problem is still the same. There is a data. We need to extract intelligence, and there is a higher value that is all for us to harness. Now, what is changing here over the period of time from, let's say, 4 or 5 years now? We see that there is a palpable change that we all feel today, and we all know today, that the global data sphere from the devices is going to be the majority in proportion. And if you just see the graph, in just 4 to 5 years or next 7 to 10 years, we'll see that the device data, which were less than 2% or 1% just 4 or 5 years ago, is going to be more than 50% in just another 4 or 5 years. So this is a very rapid change that is going on. Most of the data, they are coming from devices. And this is predominantly is what changing the entire landscape. And if you see that the number of devices is going to be multiplied by 4x, 5x, this is just a guess, but this is how the trend is going. And these devices are increasingly becoming a sort of very connected to all of us. And if we see what is the per capita usage, let's say from the device perspective, we see that it's going to be 20x in another few years. So this is a huge change that is going on. More and more devices are playing a role in our daily life. And these devices are creating a lot of data. And that data will form the majority data in just 4 to 5 years. And that will definitely cross more than 50%. Now, what are the drivers for this? And again, this is just to make sure that you appreciate the problem here. The drivers basically is expanding internet and other connectivity that we all know. The sensors and the device, the actual elements which are creating these devices or the applications, they are becoming a lot more available and a lot more cheaper. There is a fusion of internet industry network that is happening, which means that every aspect of the industry is getting automated, and they are putting sensors everywhere, even in the nuts and bolts of this stuff. And these sensors are again generating a lot of data, and they are very valuable data. Things are becoming a lot more autonomous. There is a process automation that is going on. And from the consumer internet side or from the general business side, we are getting a lot more personal. There is a one-on-one personalization happening. There is a peer-to-peer network that's existing. You can think about blockchain also more or less in the same area. Social media is generating a lot of data, the connected vehicle and virtual and meta worlds that we are talking about. So all of these things from the usage perspective are driving this new trend that we see. And if we take some of the examples here, again, just to sort of appreciate the problem here, we see that, just one simple example of connected cars or the vehicle sensor data, we are going to generate more than 1 terabyte of data per hour per car. So that's a huge data that we are talking about. And all of these data, they are perishable in nature, so which means that the value is very, very high when the data is fresh. So these are all real-time data. The cars are getting, or the vehicles are getting increasingly autonomous, driven by software. And then we see that the local or the real-time analytics is going to play a huge role here. The AI, since we are talking about a lot of local analytics, and there are several computations which, if we try to do in absolute manner, can take a lot of time. So AI and probabilistic analysis or computation is increasingly important. 5G is another thing which is we are seeing that's already arriving, and it's going to multiply the bandwidth that we have and the speed at which we communicate. So if we just see from the vehicle sensor data, it's going to multiply by 100x from 2019 to 2025. That's huge. Now, if you see the IoT smart devices, the requirement is that there are many devices at the edge level, And instead of, most of the time what we do is at the edge level, devices are collecting data and sending to the cloud or some other data center. And then it is asking the data center what exactly it has sent. So that's one way of working. The other way is that we can analyze a lot of things at the edge level itself. And we can do a lot more smarter processing if suppose we sit within the device itself, within the edge, within these microprocessors that exist. And if you are able to do that, then there are a lot of analytics that can happen right there at the edge level. And there are a lot of other use cases that could get enabled. Of course, we know that the benefits here are huge. We can understand the anomalies and the patterns that we are collecting. So for example, let's say any industrial IoT that we talk about, we have sensors there in different machines, pressure, temperature, vibration, all those things. And there are many, many more things here. So if we put, let's say we hypothetically, we have a system which can get into the microprocessor and can get inside the device itself. And it has a, let's say, state-based managed processing, which means that it can manage the state for a certain period of time. Then it has the capability of using the AI model. It has capability of storing some of the data for local transient ephemeral analysis for delta T period. And that opens up a new set of use cases that people are demanding today. So this is another example here where the trend is going towards the faster data, real-time data, local analysis, and faster analysis. The other one is, in typical business, we want to always optimize the operational efficiency. And we are instead of finding a report at the end of the day, we want to have a continuous monitoring system. And that monitoring system should be autonomous in nature so that it ingests the data, it collects the data, it processes it. When the data itself is in the wire, in a sense that it doesn't have to necessarily sit on the file system or disk. It should be able to find certain patterns and anomalies. And then it should also be able to take certain action. And if you're able to do that, then we have the scenario where not only cost saving, but a lot of predictively we can, preemptively we can monitor and stop some of the things which are not desirable. And also find out the root cause for certain problems in, again, automated manner. And then system can take care of itself to large extent if we have these kind of capabilities to handle this moving data from various sources. This is another example where things are becoming a lot more normal now, where the satellite images, especially these synthetic aperture radar that we deploy, and from there the data collection is really huge. Most of the time these data are just sitting on somewhere on the file system, but we can use this data and analyze the signature of interest. And signature of interest is very important from the security surveillance perspective, finding out certain interesting events or certain things that are taking place. And this can go a lot more deeper when it comes to typical military or the police or the typical security perspective. But again, here the problem is exactly same, that we have fast moving data, all different kind of sorted data, and not necessarily structured. And they are again containing value which is very, very ephemeral, transient. And we need to capture that, harness that as soon as possible. There are a few more examples just to make sure that the point, I'm just driving the point across really in a proper manner. Data center is another one which we think that today in a typical data center, we have tons of dozens of different tools capturing different data from routers and hypervisors, firewall and virtual machines. Instead of that, we can have a single platform which is ingesting all the data. And then since it has the ability of ingesting all the data in a single place, now it can correlate, link the data, and then it can find something interesting, security, fraud, downtime, any problem that may or might occur in next hour or so. All of these things can be found, and the cyber attack that we are seeing can be sort of tackled in some way or a little better way if we are able to ingest and process all this data together. Consumer internet is also driving it. This is less intuitive to think, but if you see, the companies are moving towards a lot more personalized treatment. They're going from segments to individual level. So which means that instead of bucketing a single person in a group, that person individually could be understood a lot better if we are able to, let's say, collect all the pixel data that he's or she is leaving, and if we're able to analyze it. If we can score the visitor on any website or any e-commerce site continuously, then we have the ability to take a lot of actions which could drive the conversion rate in the positive direction if we are able to take the action in real time. Fintech, again, these days, the fintech and the banking system, they, apart from fraud detection and stopping the security threat and all that, they want to increase the customer value. And that can, again, be done using a lot better product recommendation, not necessarily driving the sales or the revenue, but also to serve the customer in a lot better way. Industry, IoT, process automation, all of these things are clear examples that that you could see that the use case also, in a sense, is driving the trend because of the data that is now available, which earlier we didn't have. Now, if you see if we, let's say, somehow understand that there is a large data coming from devices and there are use cases and both are feeding each other, then what are the characteristics of this data? How does it look exactly if we look at little closely? So we see that they're largely unstructured. And if we go by the reports available, by IDC and the Capterra and all, we know that 80 to 90% of the data, these kind of data, are totally unstructured. And unstructured just doesn't mean that the definition of the values are not there. It means that they are binary in nature as well, apart from being textual. So they come in different shape, size, and textures completely. They are moving with very high speed and all possible directions. So earlier, we could ingest the customer data in one place and the device data and the let's say router data in another place, and that was sufficient. But now we need to put all of these data together because there are a lot of interdependency which are hiding the complex patterns that could be exposed if suppose they're set together. So data moving from all directions and with very high speed. Now, if we see, do we think that the market is also responding to this in some sense? And the answer is a resounding yes, because there is a hyper growth of NoSQL happening. NoSQL not necessarily means no SQL. It is kind of a new kind of SQL, not only SQL you can think of. And if you see, there is a 4 times growth that is going to happen for NoSQL compared to RDBMS, traditional databases. And this is mainly because the unstructured data is so hard to be dealt with, let's say, using any relational data source or database. The second is market is going to use the NoSQL a lot more than what it has been using. And there is a definite 5x increase or 6x increase in the DB market that we'll see in coming days. So this, the first proposition that the data is largely unstructured is clearly being validated by the market as well, as we see. The second one is most of these data are largely real time, which means that they are going to exist after a certain period of time also. Now, real time is completely dependent upon the use case, and it varies from one use case to another use case. Somewhere it could be in milliseconds, somewhere it could be in seconds, minutes, and so on. But the point is that we need to capture the data as soon as possible, and we need to extract the intelligence in as quickly as possible in a real-time manner. And then we see that most of these data that are coming from, let's say, devices, even log data are devices, if you consider that way, they are typically time-stamped. So they are time series data. And more and more data are time series now, and the value of data is short-lived. So we need to sort of process it as quickly as possible. There is a need for continuous intelligence. Continuous intelligence means that earlier we were fine with running the BI, the business intelligence, or running some query and complex query or some program to find out something from the data. And keep doing it in a continual manner. There is a shift that is happening, that instead of continual, now we need continuous. So 100% of the time, we need to keep capturing the data, keep analyzing, and keep taking action. So, and if we see, is it also being supported by some of the trend that we see in the market? And again, we see that the streaming database or the streaming NoSQL database is growing fastest as of now. There is a 50% year-on-year growth happening for streaming and time series data processing platforms. And this is, and the growth is going to be humongous, not necessarily linear that we are showing right now, but this is again being supported by the market very, very clearly. The third characteristic is largely predictive. And the reason is, as you see, the data is fast moving. There are a lot of data, and there are a lot of complex patterns that are simple patterns that are hidden there or could be extracted. Now, there are two ways to do it. One, that we run a program and we find everything in absolute manner with 100% confidence. But that takes a lot of time. That will beat the overall purpose of the real-time continuous intelligence. And the second one is we use predictive model, where we, with certain confidence, we tell that this is going to happen or this is not going to happen, or this is the pattern, this is not the pattern. And we are okay with that margin of error. Then the predictive analysis will actually cater to this real-time continuous intelligence if applied properly. So predictive analysis, again, is going to be the major part of the process. And in fact, as you see a little closely, the AI or the machine learning is no longer a different, divorced entity from the data. It is very much now becoming the part of the data itself. AI cannot be separated from data, or you cannot think of data to be carried to the AI. It is just the other way around, where AI is coming and fusing with the data. So AI is required for most of these processing. And again, if you see from the, so this is no brainer, everybody knows that the AI is growing very fast, and there is a humongous growth, and we can't even predict how fast it can grow. But one thing is for sure, that for every humble use case that we even had like 20 years ago, now the same use case is demanding the predictive treatment. So AI is naturally becoming the part of the process. And then we see that since we are talking about all kinds of data from all different directions, but they're not disconnected in a sense. All of them put together, they will tell a context, they will tell a story. But that story could only be told if, suppose, we have the ability to be able to put all of those data in a manner where the natural groupings, the natural connections or the relationships are also preserved when we store that data in any database or file system. So which means that data is interconnected, networked, and they're interdependent, and we need to preserve that. And hence the graph and the ontology or the knowledge base that we're talking about, or the property graph, all of these things are becoming, again, a very critical element. Now, this is also very important from the AI perspective, because graph, in a sense, or not only graph, but each of these elements are again supporting the other element. For example, having a graph structure within the data and be able to utilize that, the context for, let's say, AI or machine learning, suddenly the model starts behaving a lot better, because now it has the context also in place. And there are many other benefits that we can cover. But again, if you see, is this being supported by the market or what's happening around us? And again, it is definitely going on. It is growing with more than 22% per year. And again, feeling is that it's not going to be linear, because it is kind of becoming a very nice replacement for relational database as well. In relational database, typically we define the relation, but at runtime, we need to compute that. For example, if you run a join query, you need to compute a lot of things. In graph, you can have the same relation, but you can totally avoid that computation, because that is naturally reflected by the relationship itself. So graph is becoming important from many, many reasons. There is definitely technology that is also growing and supporting all of these. mostly from, let's say, hardware network, if we just see from these two perspectives, because software we just saw. And we see that there is of course, this is happening, not yet, we haven't yet experienced it, frankly, but even the current existing model is improving. And very soon 5G is already there. IIT Madras, I think they have done it, and the other guys are doing it. So 5G will be there very soon, and we see 25x jump. Now, we can only imagine what's going to happen if suppose we get this much of bandwidth. And if today we are struggling with 40 Mbps, 40 MB per second, how are we going to tackle this with, let's say, 1000 MB per second? So this is definitely is going to fuel the use cases and the demand. But the technology part, the other technology from the software side, are we truly ready to tackle that beast? The second is, we have seen this over the years, and it's still happening, that SSDs, the solid state devices, they are getting cheaper, faster, and a lot more reliable. Reliable because earlier the life expectancy was low. It is, as you know, it's a NAND gate based devices, and these guys have a lot of cells, and each cell have a limited capacity for a number of writes that one can do. But this is improving, and there is if you see, SSD sits very nicely between the hard disk and the RAM. It is costlier than hard disk, but much cheaper than RAM. It is faster than hard disk, but still much slower than RAM. So intelligently, we can do something and use it for our benefit. The third one is the sensor cost. Another thing is decreasing very, very fast. And like a hard drive, this will also become almost dirt cheap in coming days. So this also, if you see, try to put these 3-4 things together, you see that apart from the software, these are also sort of supporting the or going to only increase the trend that we see today. And if we just see that, what is the major change then? What has happened with all these things that we discussed? The data coming from various sources, hardware supporting it, network supporting it, and all that. The major change is that we suddenly, even for humblest of the use case, we now need multiple systems in a single place. We don't necessarily need only one thing or maybe two things. We need all of these things together. And let's say if we have the data, then it's sure that we are going to have more than one kind of a data. Even if, let's say, it's a text data, there could be a data suitable for document. There could be another data suitable for column. There could be some data which is opaque in nature. So even for one kind, there are multiple sub-kinds there. Then, since these are flowing from different sources, and they are mostly time-stamped, so there is a case for streaming analysis, which means that we should be able to do what we call map update rather than map reduce. If you see, SQL is just a map reduce process, which means that we first persist the data and then we try to do computation. It's just the opposite. Before persisting, we'll do a lot of computations, and we keep the data in a shape and size which can be consumed very easily when it is required. And apart from finding the anomalies, patterns, running statistics that we definitely do using the real-time stream processing. Then, as we discussed, we need to use certain model. So now the question is, can we take the data, export the data to some other system and train model there and bring the model back to the system? Then it remains a manual process. Second, what can we keep training this model with certain frequency in automated manner? Can we analyze the efficiency of the AI a lot better? Is AutoML possible if suppose we have that kind of a case? And the answer is largely no, because we need AI to be right there where the data is. Since data is coming from us are different sources and there are different connections and relationships, so we need graph processing. And finally, this is also very important that in many cases, we need hybrid deployment. By hybrid deployment, I mean that we can no longer just have a single deployment on cloud or let's say in local area network or somewhere where we keep sending data in some manner, either streaming or batch manner. Batch definitely is not recommended. And the reason is because there is not enough bandwidth or infrastructure available to send everything from the edge to the cloud. And Snowball from AWS is an example where they send 120-tire truck to upload data and download in data center. So which means that we need to sort of analyze and process a lot of these data at the edge level itself, and preferably within the devices. And then we should have a local deployment as well. And then there is a cloud deployment. And all of these are interconnected. They are hybrid in nature. They are totally heterogeneous, but they are connected. And so this is kind of, at least at the minimum, we need to do this in order to tackle the newer kind of a trend that we are seeing. And then before we take a break, I'll just cover the challenges part. And after that, we'll take just a couple of minutes of break to see if there are any questions. So what are the challenges that we have in the existing architecture? Let's say if these are the problems, this is the trend, this is the market, this is how market is responding. There are use cases which are supporting it, and there are some potential things that are going to happen in future which will further support it. So what are the challenges then with the existing architecture? And the problem is that most of the systems that we have in the market, there is an upfront stitching that we need across these different components or different systems. And even if they are siloed, we need to sort of somehow stitch them together and do something. So this is largely onus is on the developer or the organization who wants to deal with such things. And then we say that while most of the tools and technologies, or especially the databases that we see in the market, especially in the NoSQL area, they claim in memory as a feature. And according to me personally, and largely many people, that in-memory computing is not a feature. It's a bug. It's a limitation. It's a limitation which we treat as a feature. And the limitation is that if memory is full, then we can't process the data. And so we need to break out of this, because now, since we are ingesting data from devices or all this data, which are high-speed data, the volume is not known completely, and it can fill my RAM very quickly. And I cannot just start denying the processing or ingestion of the data just because the memory is full. So data is outgrowing memory faster. And adding more memory like HANA is also not a solution, because then it becomes we need to buy certain elephants. It's so costly, $1 million expense that we need to incur upfront before we start even thinking of processing the data. So we need to get out of this in-memory only computing platform. Then singular treatment for all data is very limiting, which means that we have, as I said, we have a data which requires different data requires different kind of treatment. If we take one data platform, then it will enforce all the data should conform to a singular format, and then we can do any processing. And that's the impedance, that's the resistance that we need to remove, because it is not only tough to ingest all the data in such platform, but also how do we now correlate the data, link data, and keep the natural intelligence of the data as it is within the data platform. So multi-model is the key. And then we discussed that AI and graph and streaming, they are becoming natural elements. So for most of these use cases, if we don't have that, then it is non-starter. And training is still okay if suppose we can manage somehow, but for deployment, auto ML, prediction, all of these things are required when if AI is there, right, with the data. And then we need to have a deployment model which is a lot more heterogeneous. We are not talking about intra-cloud operability and all that, but this we are talking about, can we have the system deployed in the devices and in the cloud, and they are completely okay with each other. And then this is also very important, according to me, that the most of the systems that we see, and especially again in the NoSQL area, they lack the control on the data that they are ingesting and processing. We need to have a lot more control on the data. We need to reduce the network hops. We need to reduce the multiple copies. And the core point is that most of the tools and systems that we have in the market, they were actually designed, if you see, decades ago. So they were designed for totally different kind of a data, and rightly so. But now, since the trend is there and things are changing, we must have a newer kind of a model, a newer structure in place, philosophy and architecture, which can tackle these data a lot better. So I think I'll take a small pause here to see if there are any questions and then try and answer.
Yeah, I think you can start putting the questions in the Q&A box. So meanwhile, I will just, some questions are there. I'll just start with them. So with Industry 4G coming into picture, data spheres of different nature and challenges are to be addressed. So he's talking about Industry 4G, 4.0, I think his meaning. And coming to picture, data spheres of different nature and challenges to be addressed. So it could be, say, for example, machine-to-machine connectivity.
Yeah.
With the 5G comes with, say, in-company kind of licenses people are giving today, connecting the shop floors and other things. I think, so can you just touch upon that point?
Yeah. In fact, if you see, largely the data is generated by machines, and the machines are actually interacting with the other machines. The data generated by humans are going down significantly. And that's what the first slide was talking about, that the data from devices are increasingly rapidly, and very soon it will be in majority. So now the question is, today it is traveling or communicating with each other over a certain bandwidth. What happens if suppose there is an extra bandwidth available? There is no dearth of data that can be communicated. If you just say one simple Linux server, we can have that Linux server generate more than a few GBs of data very quickly. And all of these data are important. Now think about the vehicle. We are right now throttling it to make sure that it is generating less than a terabyte an hour. It can generate a lot more. Now, if suppose we have the extra bandwidth available, definitely the user would like to access more data and process more data. So that is not going to be a huge challenge, because it is definitely going in that direction. But the problem is there a software available? Is there a technology, or at least the understanding is there, whether how do we process that amount of data, when today we are struggling with the existing bandwidth that we have. And that's the moot point. And it is mainly because it is not because users don't want to do that. It is mainly because we have lack of means to handle that kind of a data. So it is only, we can all imagine what will happen if we have that much bandwidth available. So for that, let's take an example of even a simple smart home or connected home. Typically these, in any society or any, let's say there are 100 such smart homes are there, they're generating huge amount of data. All are trying to send to some remote server, and they can generate more and more data. So they are throttling it, send data every 1 hour, send data every 3 hours. They can send data continuously. Similarly, right now 10 data points per second is what the vehicles are supposed to send in a short range communication protocol that we have. We can actually modify, tweak it to send a lot more data. The amount of data that we are piggybacking on each TCP hop, we can actually increase it. And those are going to be definite possibility in just coming few years or months. But the point is we don't have a system which can sort of at least ingest first and then do certain processing.
Okay. Yeah, just a related question to that is from another person. So this is more, so what will happen to, now you're talking about the output. Once the data comes in, you're processing it and making it high speed, streaming and all that part. But there are a lot of investments are done in a lot of these devices, equipments in every industry. For example, in the automobile industry, or we've got, today they've become much more intelligent, like CV they use, computer vision they use, a lot of stuff they use. And also in other things like healthcare industry, a lot of devices are all there. I think many people are contemplating that even if patient is in the ambulance, can he be tracked
Yeah.
in an emergency situation from the hospital, so that when he comes to the hospital, already the thing is known what to be done, kind of a thing. So in all these things, what will happen to these equipments? You have to put some retrofits, or what kind of retrofits they are, hardware or software, kind of a thing. Yeah.
So I think, if you see, largely I'm talking from the software perspective, in a sense that the software could be used on the existing hardware. Now, if suppose hardware is missing certain parts which is desirable, it should still work. So for example, let's take an SSD, here for in this particular scenario. If we have the solid state drive available, we should be able to use it a lot better. But if it is not there, it should still work, and it should work better than earlier software version. So this is all pure software stack, which is going to work on the existing hardware. And it is kind of it is not going to require a different assembly of systems. That's one point. The second point is that in coming days also, if we'll see that there are going to be dozens such requirements and dozens such system, and they will have to interoperate, cooperate, and coexist also. There are certain use cases which are completely suitable for what we have today, and it will continue to do so. But there are newer kind of use cases which will demand certain extra thing. So to my mind, first is that software will work on the existing hardware, and if hardware is improved, it should harness that better. And the second is that there are going to be more than dozen such systems in a typical place to handle different kind of use cases. The only limited point I'm trying to emphasize here is that the use cases that we are talking about are really increasing rapidly.
Okay. Yeah, I think this question comes up in everything we talk about, the personalized data protection, because it's processing on the fly. What will happen to the personalized data? I mean, because many situations they're talking about consent-based sharing only. So here it is picking up on its own. So what will happen? Yeah,
that there are. I mean, it's a big topic, by the way.
Yeah, I understand.
But if you see from the design and software perspective, the whole proposition is to deal the data from P2P perspective, peer-to-peer network. So there is a data network overlay, which is P2P, and the distribution of the nodes and the data is completely dependent on the hashing, consistent hashing that we deploy there. So in a sense, data is a lot more protected versus what we have today, because we know that the data is going in this system, which is not designed exactly like the P2P network that we are talking about. So there is an inherent protection there from the privacy perspective, that it is largely unknown where the data will finally sit. The second is that all of these are going and ultimately going to sit in a database in a binary format. So those things are there. But the other questions like, can we collect the data? Can we process the data? Can we analyze the data? Can we use the intelligence? These are all good questions that is totally not part of this discussion. Yeah.
Okay, sure. I think you covered the general industry trends where things are moving in this direction and the kind of challenges we face. So can you just touch upon what your company is doing in this ecosystem, and what else, and what are the further challenges you face, and what needs to be done to address some of those? Yeah,
sure.
Go ahead. Yeah,
absolutely. Okay, so we just touched upon this, that the challenges part, and now the question is then how do we tackle this? And this is what we think that this is one of the ways to tackle this entire problem. And the problem is that if you see from high level and try and sort of understand what's happening, is that the problem space has a natural convergence of various requirements in a single place or at the core, which means that they are converging different requirements. Earlier, that were different requirements for different use cases. They were taking all those things and converging it into the single problem space. So this is what we see from high level. So our proposition is that we must also converge the solution space to counter the same, which means that we need to bring all of these things in a single space, in a truly in a true fusion manner, not the siloed integration. So all of these are complete fusion of different components and elements into the converged space that we're talking about. And so if the problem is demanding different deployment model, we must have that as a natural part of the system. If we want to deal with multiple data types or the models, then we should have those things already implemented in the system. For example, let's say graph or large data or document or time series. It should just be a natural part of the system. The streaming should be inbuilt within the system, and of course the AI and ML as well. And all of these are, as I said, not the horizontal or vertical integration. It is the pure fusion of different elements into the single system. So that's the very high level philosophy, that the problem has a convergence, hence solution should also offer a counter convergence. And that is a shift from the traditional architecture, and it's little bit, there is a humor also here. If you see, we started with a monolithic architecture, and then we said, this is not good. Let's go 2-tier, 3-tier, and N-tier. And now we have a mindless tier, number of tiers there. And what we are proposing is that we need to sort of converge these different elements and make a unit of compute. And that unit of compute is linearly scalable. So what we are talking about is that in a typical sense, let's say if we want a drop of water, then we should get a drop of water. If we want a glass of water, then we should get a glass of water. And same is true for, let's say, bucket of water and beyond that. What is not changing here is the property of the water. We are not giving hydrogen and oxygen and then asking people to combine it. So splitting the system into multiple different heterogeneous components, and in the end combining them in order to serve the user or certain use case. This is one way of doing the computation. And we are proposing that we should transition from that. We should create a unit of compute, and the size of unit of compute is completely configurable. And then if we have that, let's say, model in place, then it's very easy to keep adding the unit of compute, and it becomes a truly throw machine to scale model. So it scales linearly. So this is the traditional architecture on the left side, and versus the convergence, and it becomes a completely autonomous deployment or system as well. And so what we achieve is that it breaks the tech silos, and then it actually allows you to put different things in a single place. The second one is scaling is very easy now, because literally you have to just add machine to the ring, and the ring itself ingests the machine in its own way. It has a reduced latency. Now think about a case where there is a ingestion layer, then there is a messaging layer, then there is a batch processing layer, then from there is a store in a NoSQL data store, and then from there to BI. There are tons of, and each of these verticals is a distributed, they are distributed in itself. So the packets are getting copied and hopped from one machine to other machine in the same silo and then across the silo. And that kills the latency. Even if you take the computation part as 0 or the time as 0, the network hop and copy of data is so much that we cannot achieve the latency that we are talking about. And then it is, of course, very simple to manage. But the problem is, how do we converge all these data and create a unit of compute? So this, again, it's not something new. It has been existing for some time. We have just borrowed the concept. And this is, so we use the SEDA approach, stage event driven architecture, where we create a unit of compute by having very largely this kind of a model. and there are multiple handlers, and these handlers could be anything, and it could be totally configured by the user. And if we have that, then it's very easy to sort of, let's say, configure it. So for example, let's say we want to just do a single operation, we can have the stage defined like this. And these stages or the handlers are just sitting there in that unit of compute. And it could be complete in nature, it could be partial in nature. So basically what we're talking about is a finite state machine. If there is a task, which is a set of S0 to, let's say, Sn, and we want to sort of perform these tasks, then we can logically put this task in different buckets. And those buckets could be called different stages. And these stages could be configured in many different ways. And then the events or the data that we are ingesting, the processing is nothing but the FSM. And if we are able to do this, then what we are essentially doing is we are putting the different elements within a single unit of compute and making sure that that unit of compute is ingesting and performing every single thing that it is supposed to do. So this is one way of doing it. We have used this SEDA model. And so the second point was that I raised was that we need to get out of memory as soon as possible. And if you see if you just take that example that the data is multiplying 10 times every year or so, the volume of data is increasing far greater than the amount of RAM being available for the same dollar. So data is definitely outpacing the memory. So instead of sort of assembling multiple RAM and more memory for the data, we should think about using SSD a little differently. And so what we are saying is that if you think of solid state drives, and if you consider it, it is still a drive, it is still a hard disk, it is still a file system. So which means that we cannot simply take and use it as a replacement of memory. But there are certain disciplines that we can follow, and we can write some software to treat the SSD as an extension of virtual memory rather than a replacement of a file system. And if we are able to do that, then we are creating a scenario of logically a poor cousin of the memory itself. So instead of becoming a faster hard drive, it is becoming a slower RAM. And that slower RAM is still much, much faster than the faster hard drive. And of course, there is a software IO layer that has to be written. So this is also something that we have done. And it works on any commodity, the file system that we have. We don't necessarily need a new file system like X3, X4 file system on Linux side. This IO layer is part of the database. And if SSD is available, it leverages it as an extension of memory, virtual memory. And when we do that, then we bring the flexibility. Then the brittleness is immediately gone as far as the in-memory computing is concerned. Now we can gracefully degrade the performance. So instead of dropping the packets once the memory is full, we degrade the performance over a period of time. And until there is a limit in that band that performs really well. So we have enough bandwidth, enough time, and enough resources and flexibility with us to add new machine or go beyond that particular resource. So this is a huge thing, because most of the time the problem is that when my memory is full, the packet starts dropping, and that droppage of package will have a lot of patterns and a lot of things that will get broken. And even if you, let's say, sort of assemble a new resource, that packet, those data points are already gone. So this is, and then it actually avoids, allows us to add SSD as much as possible within the range. And then we can go with extra RAM if possible, or other machine. So there is a cost implication directly there. The RAM is costliest item there, and SSD is getting cheaper. So if we use this, we also optimize cost, and we become a lot more sort of flexible here. The third part, what we have done is we have created the a continuous sliding window stream processing system. And the database, when we ingest the data, it can pass through this whole stream processing engine, and we can do the complex stream processing. With this stream can also push data to the graph, so we don't necessarily need to send data to the graph. There is a continuous running aggregates and statistics here. We can deploy the model on the streaming data using the streaming data itself, and we can automate the process. And there are many things that further could be automated from this. Now here, the important thing to note, as I said earlier, is that we strongly follow map update model, which is like processing the request first, slicing and dicing, processing, keeping things in a format which is readily consumable, rather than persisting the data on the system and then do processing. So this further allows us to do the real-time computations. So now AI is native part of the database, so which means that we don't necessarily need to export the data to the other system, but we can use the AI right there where the data is within the database. It has, the AI is more and more becoming part of the query itself. So many times we don't even need to necessarily explicitly train the model. We can run the query, and query itself takes care of things. So it is a lot more abstracted, and hence it is a lot more easier and becoming autonomous. And the BankDB has the support of large files. So which means that we can store the models, the related files, the binded data, everything. And it is not necessarily about all the text data. This is true for any images or videos also. And so GB can keep those things as well. We call it resource server. And this is how we process. Again, this is based on the same P2P model, where the machines are again distributed on the virtual network overlay, and we can import any external framework here we want, and it's just a simple configuration change, nothing else. And even the TensorFlow and other thing could come and add here. But the important point is that the entire orchestration is within the database with zero data movement out of the system. The graph and Cypher, this was very important for us because most of these data are interconnected. There is the group, there is a click, there is segments that are available naturally. So if we put the data in a graph store, and which we don't necessarily need to do it again explicitly through stream processing, it happens, then we can leverage that. We can write a Cypher query, and we can do a lot of things. In fact, the Cypher query has a data science integrated. So if we want, let's say, we want to understand the, let's say, a similarity between two nodes or two different distant entities, we can simply do it using query, which in turn will do the all ML work internally, and then give you the score. And then you can persist that thing also within the graph as different relationship. And that is very handy for next operations. Same thing is with the clusters and all that. Multi-modeling is important part here because we deal with all sorts of data points. I don't need to necessarily cover that in detail. But important point here is that when we have, let's say we want to use only key value data, and we use Redis, let's take for example, and we want to use document, then we take MongoDB, and then column we take some other. Then even if we want to live with that scenario, how do we link this data? Who will do the linking across different products? So this is again a developers or the organization's problem. When we have the multi-model support here, then we can store the data in different places, and we allow the information to flow from one side to another side, or the linking can be done. So this is another byproduct of handling the data in a different manner within the database. So we implement all these, and naturally we also store large files and objects. we have a hybrid deployment model. So you can compile the entire system in embedded manner, and it fleshes out a little bit, and it keeps the unnecessary thing for, let's say, ARM processor or whatever processor you are compiling it for. And then it creates an embedded version of the database, which can get inside the microprocessor. And it deals with the older microprocessor limit, so which means that it is very comfortable with the latest limit and all that. The second one is you can also use it for a small cluster or local deployment, like client server model. And it is also useful in many sense when we don't deal with a lot of data, or when we don't want to persist a lot of data, or you want to just use it as a data buffer, which process a certain data for a day or two, and then keep syncing with some other system or the BankDB in the cloud. And then there is a fully distributed masterless P2P network. And here we use consistent hashing. We follow the CORD algorithm, and we distribute. We create the virtual network overlay. We distribute the nodes and data using consistent hashing. Now there are tons of challenges here, which I don't want to go into today, because it is very easy to do, let's say, P2P in DHT kind of environment, which is a distributed hash table, or let's say ledger that we want to process in typical blockchain or something. But when we want to deal with, let's say, streaming data, or the data which is scannable, or where the range query can be fired, then it becomes very complex and challenging. So there are a lot of things that we have done in order to achieve those things as well. And there are certain changes here, not exactly as the pure virtual network overlay, but we have made some changes in order to align with the problem here. And if you see the actual implementation of BankDB, so it's a NoSQL database, which means it has a key value store. It's a document store like MongoDB. It can deal with large files and large objects. It has a graph structure natively there. It supports transaction, and it has a query support, both SQL-like query and a Cypher query, and it is fully distributed. At the same time, it is also a graph store, which means that it has a concept of RDFs and entities and relationship. We do support Cypher query with data science, and there is a ontology knowledge graph also we can store. There is a property graph and the knowledge graph. If you want, I can describe that a little bit, but basically we have multiple different kind of graph support here. There is a native stream processing, which means that deal with the time series data, do the real-time analysis, anomaly, complex patterns, identification, all that. And this allows us to ingest and process and take action in continuous manner. And then there is a native AI there. Some very high-level details, again, just for the consumption from the, mostly for the users. So, I was just touching upon having a full control on the every single byte of data that we ingest. That is kind of a requirement there, and it is mainly required for many different reasons. One is definitely that we want to get out of memory, and we remain operational even when the data is suddenly beyond memory. The second thing is performance. We can achieve very high performance if we know what data is being written or read, and then we can take certain actions. And the third, there are the entire concept of the SSDs and all that is largely based on this. And the fourth one is that we get out of the operating system being the democratic in nature mode. So what I mean by that is that if we run a program on operating system and we let the operating system manage our data, then it is going to be democratic in nature. And then even if it is not democratic by setting some priorities and all, even then we don't have the control. We don't even know which data is being written or read. And if you see most of the NoSQLs like Mongo, Redis, and many other databases, they use simply called mmap, a memory map concept, which is just an operating system construct, and which gives you a block of memory, and it manages that memory on behalf of you so that you don't have to manage the memory. Now, we needed to get out of that in order to achieve the few goals that we had set out. So what it means is that we must have the page cache, we must have buffer pool implemented right where the database is. And so we implement the buffer pool page cache. And then since we have the AI there, so we use that, we kind of dog food that, and we use the predictive analysis to also figure out the probable pages that are going to be read or written in coming, let's say, next second or next few seconds. And then we take certain actions. So this overall things allows us to go very high in performance. And then we use a lot of indexes. As I said, although we call ourselves as a NoSQL database, but we come very close to the relational when it comes to certain discipline like indexes, write-ahead logging, buffer pool. But we don't cross the boundary and become like a relational. So we have multiple indexes in place. There is a reverse indexing also there, which allows us to run the query a lot faster. There is a write-ahead logging, and most of these places we have tweaked the concept, and we filed for patents also. Few patents we've already got, and around all these area, buffer pool, write-ahead logging. So there is a durability here naturally, crash recovery and all that, and apart from transaction. And then it is written completely, mostly in C, 90% in C. And we compile in C++ for various different reasons. And there are clients, there are REST API available for each and everything that I talked about. There is set of REST API available. There is command line interface, and there are multiple clients available for user to use it. And this is a very high level view of the BangDB stack. And you will see most of the things that I was talking about kind of layered here. So starting with the IO layer, which is right at the bottom, and which is responsible also for using SSD in different way. Then the buffer pool and that. Then we have different models of data, then analytic layer and so on. In the end, there is a network overlay which actually distributes. And if we don't include that, then we can sort of, in loose sense, we can compile it for devices also. And on top of it, there is a dashboard also now. And this completely interactive dashboard, which people can use and deal with BangDB. Now, so far now, if we see that we have done all these things, so what are the benefits here? So there are many ways to sort of quantify or objectify the benefits, but performance is just one of the dimensions. And I picked this one because since we talk about multi-model, we talk about all these things. So it is good to see, are we losing anything when it comes to performance when we compare BangDB with, let's say, totally dedicated data platform like Redis, which is a dedicated for key value, or the Mongo, which is dedicated for document. And then we see, how do we perform? And this is done on YCSB, and there are again some third-party benchmarks also available, but this is most conservative one. And we most of the time we are performing 2x, sometimes even more. And individually, and BangDB just runs in a normal way, where if document is given, it just writes document, and or if you give multiple, it will write different things. Then again, to make sure that we understand the importance of the in-memory part that I was talking about, this is a very good example for that. So Redis is completely in-memory database. Beyond memory, it doesn't work. And the first one, if you see, after a point when memory was full, it just completely went silent. And the performance was less than 100 IOPS or even less. And it took a lot of time, 4 times, 5 times more than BangDB took for the same memory that it had. And it's mainly because it totally depends on the in-memory computing. And this is what I was trying to talk about. And the second, if you see the read part, there is no Redis graph there because Redis couldn't complete in 2 days also. and it's just data points. Yeah. This is another one, again, to emphasize the importance of the architecture that we are talking about. This is mostly from the this is for Level DB, which is from Google, but it is written for different purpose. But it is written mostly for sequential data, and it uses mostly used in Chrome and other session data and cache data. So which is mostly sequential in nature. But the important point was that being random is key here for our use case, all that we're talking about. We can't be sequential. And if we use some similar platform, then again, same problem. If you do random operations, even though memory is available, some of the database won't perform properly, and it takes a lot of time. This during sort of a project or something, we integrated BankDB with HANA, and we put BankDB in front of HANA, and we were doing the data ingestion and processing, and we are pushing the data to the HANA. Every single event, we are pushing data to HANA also. And we face that after a certain point, even though there's a lot of memory, the HANA stopped ingestion. And it's again, same problem that most of the time we were talking about. This is basically from what we have been doing. We sort of saw that there is a problem, and we thought we could create a new model to create a new system, which is very different from how things are there in the market. And then if we can see some benefit, then probably there is a use for it in the coming days. And this is just to showcase that, what are the different dimensions that we discussed so far, and what do we cover and what others are trying to cover. So I think that's it from my side. Mostly these are the things I want to cover. I'll go back to questions again, if suppose there are any questions.
Yeah. So just one, other than a question, more of an inquiry. Has IQLECT has gone commercial now?
Yeah, this is it's available. So there are three. You can download the community version, which is completely free of cost. There is a SaaS version also. So you sign up and you get on the cloud immediately, which we give a dashboard, and you can interact with that. And then there is an enterprise license. Yeah.
Okay.
We have a lot of developers using it.
So you have got some industry use cases in different situations and all that.
Yeah, I mean, some interesting ones. People are using in totally different ways. Also, we are learning there as well. But we see that performance definitely is something which they see, and the graph and other integrations they are appreciating.
Okay.
Yeah.
And I think another question is if already people are using HANA, it's quite popular.
Yes.
So your thing can go as accelerator to that kind of a thing, which can be.
It can go, sir. But the way I see it, HANA, you need to pay like millions of dollars to get started. Suitable for certain use cases. Here you can get started with $0 and pay as you go.
Okay.
And then of course it can sit before the HANA, as you said rightly, act as a fast real-time buffer also. But they've got HANA Lite as well, as far as I know. So I don't know how this will pan out. But ours is, and then there are relational in memory, and there are tons of things there.
Okay.
The appliance, and they work on their hardware.
Okay. I think the another one, Pravat Jena is asking, can you share one of the industrial use cases?
Industry use cases.
Yeah.
Okay. So there is a use case where, let's say, and this is again some of the use case that we have tackled. So I was also touching upon this one. So in a data center, typically, if you we start from the firewall, then there is from their router, then switches, then hypervisors, virtual machines, And these are all data that are not application specific data and network data and all that. Today in a typical data center, you will see different tools for different data points. So we deployed this single instance on one machine, but it was a large machine, and around a terabyte of data ingestion per day, and all kinds of data in single place and processing. It enabled the visualization in real time. Then processing was done continuously, and then some of the models that eventually got trained because data were there in the database and AI is right there. And then eventually we started solving some of the complex. So this is just one case. The other one is, the various. Now the other one I will cover from the unstructured, totally unstructured side, which is the lot of data and documents that are available within the company, and we can use that to improve the customer CRM touch point. Because we can take the knowledge base, put that in an ontology and graph, and understand the user question and respond with answer, and also improve the backend processes, which is assigning the tickets to right team. And there are a lot of mistakes happen there, and a lot of things are still manual. Third is the recommendation or personalization that you could think of. Again, this is all dealing with high data volume and fast moving data. So I took 3 different examples from 3 different areas where it has been solved on BankDB. The other is people are using it, like for example, there is an organization who's using it for user profile data, because user profiles are accessed very very quickly, and it's a read-write web kind semantic web aligned problem. So there you need something like this. The other one is the serving of, let's say, the images, and that has to be done really fast. And then some of the metadata that you can harness in order to understand the query, and the right image could be served in a lot more probabilistic manner. So most of the use cases that you saw in the PPT are the use cases which are kind of done on back.
Okay. Just taking on from there, see, typically this is the challenge faced by most of the startups. As you start implementing more and more use cases, a lot of new developments may be required.
Yeah.
And also putting that in the field kind of a thing, and growing. So most of the startups face this talent resource crunch kind of a situation to develop all the new activities and all that. So I just want to suggest one thing. See, one thing IITACB we are doing. We've got 23 IITs in the system. We know where the people are working in different areas and all that across IITs. So if there is some challenging problem is there, many of them are focusing on, apart from the basic research, on translation research also. So if any of the challenging things are to be done, either to address an opportunity or to develop something new for the future thing, we can put together teams from the multiple IITs, and you can work with them directly and get the things going. And IP belongs to you. So that is the key thing.
Oh, okay.
So you may want to consider this as you move forward.
No, absolutely, you are right. There's a lot of challenges here, and focusing on too many use cases versus the single use case. All of these things are good.
Because once you start doing it, then it may fall into some pattern.
Yeah.
Then they can develop some technology or IP for that particular pattern or sector or whatever it is.
This is a pretty now it is in a very solid state, the IMDb, and whatever we talked about, everything is there. Every single thing is there, and people can use and see, what are their experiences, and it can solve a lot of problems. That's what we feel.
Yeah, very good. So I think there are no more questions. I will hand back to. So thanks a lot for interesting session. I'll hand you back to Sushila.
Thanks very much, Anand, and thank you, Sachin, for what I think was an absolutely mind-blowing insight into the world of data and what we can do about it. of course, we all are aware of the absolute explosion in data over the last several years. And even in our webinars, we've seen several examples of this. We've had webinars in the area of AI. We've had, we've even looked at mining and how, and, an industry that you would never imagine would get automated and would generate data like mining, too is doing that. So we've seen that. We've talked about, autonomous vehicles, IoT. So we've seen that even in several of our webinars. So this particular webinar was an important one to kind of tie it all up together and say, what do we do about this data? So Sachin, thank you for readily accepting to do this and also for sharing so readily. Just a few quick summary points. Every aspect of industry is automating, and with this we are going to see, along with trends like personalization, peer-to-peer networks, social media and metaverse, etc., we're going to see an absolute explosion of data. And what do you do with all of this, more importantly, as well as to respond to the kinds of situations that organizations and individuals are thrown into? We are going to need a different kind of mechanism to analyze and make sense of all of that data. So the question that Sachin posed to us was, what if the analytics also sits on the device itself? It's, the device is not just about storage, it is also about analytics. And what if you could store, analyze in real time at the device itself? Why that is important for things like predictive analysis. And then we saw things like the signature of interest from satellite imageries and many other such examples of how you can look at data and where it all could potentially reside. And the other interesting point was that 80 to 90% of all data we expect is going to be completely unstructured, which means that we definitely need to have a new way to store and process data. AI is going to be integral, completely integral to the data and the processing. It's not going to be a separate thing anymore. And the shift in the approach to the database itself, which is what then brought us to look at what has BangDB done and how is it all organized. The advancements and what was it that enabled all of this to happen? Technological advancement in hardware and networks, huge bandwidth, lower latency, higher penetration. All of this is going to mean that there will be newer and newer use cases for data consumption. SSD is becoming cheaper, faster, more reliable. Again, another reason why much more can be done at the SSD level itself. And of course, sensors and the amount of data they're all going to throw up. So what we saw finally as the architecture behind BangDB was text, image, video, all kinds of data, streaming at real time, AI built into the database itself, graph processing, and then very importantly, deploying in a hybrid manner, both at actually 3 places, at the device, at the edge, and in the cloud, all simultaneously. And how do you make sanity out of all this, and how do you keep it together? And then, of course, we looked at challenges with the existing architectures, and finally, Sachin talked us through the solution and how it has been realized within BangDB, how the database has created a converged space of solutions. And this is a tight fusion. It is not a superimposition of different approaches of different aspects. How BangDB depends on creating a configurable unit of compute, which is what gives it the ability to scale linearly. And then we saw we saw a lot of the data around, a lot of information around the way BangDB is organized and the various aspects of the database itself. We saw various characteristics. We saw what the stack is like, the BangDB's stack is like. And we also saw the benchmarks against various existing databases. And I must say, Sachin, that it was wonderful to hear about this absolutely innovative design. And it just from all of us in IITACB, we want to wish you and your team all the very best with what we think is a wonderful initiative. So our audience, thank you for being here. Thank you for participating with your questions. And we look forward to meeting you, of course, in a couple of weeks from now. Sachin, once again, big thank you from all of us for so readily accepting to share all of your experience and knowledge. And Anand, thank you very much for moderating this so well. So with that, goodbye.
Yeah.
No, thanks a lot.
Thank you, Sachin. Yeah.
No, thanks. Thank you, Dr. Sushila. And thanks for giving me this opportunity, actually. Frankly, I've always been looking out for such opportunities, and this was a great session. I enjoyed it fully. We hardly get chance to talk about technologies these days. So this was a good discussion. Thank you.
Wonderful. Thank you so much.
Okay. Thank you very much.
Thanks.